Hello, welcome to CPP Chat, the least secure podcast for C++ developers by C++ developers. Before we continue, I'd like my fellow host, John, to read this week's disclaimer.
Thank you, Phil. We hope that our security systems provide some deterrence to crime. However, the podcast can never be crime-free. For example, it is possible for someone to enter your property under false pretenses to commit crimes, for residents to commit crimes against their own neighbors, for guests of residents to commit crimes, and for employees to commit crimes. As a result, the podcast cannot guarantee your security. You should not rely on the podcast to protect you from loss or harm. You should provide for your own security by keeping your doors locked, refusing to open your door to strangers, asking workmen for identification, installing a security system, carrying insurance, etc. So, welcome today. We have three individuals who have not been on the show before, but I think we're going to have some fun with them. Ava Conti is a graduate of the School of Hard Hacks, specializing in social engineering. Ava, do you want to share any social engineering stories with us?
That depends how many law enforcement people are in the audience today watching.
Oh, there won't be any. Be fine.
Maybe there should be.
Who knows?
That's for us to decide.
Yeah, all right. Matthew Butler is also joining us for the first time. He started out as a hacker and has spent the last 3 decades as a system architect and software engineer, paying for his sins. Matthew, do you have any confessions you want to make?
Yeah, so you're having your worst day as a systems administrator when you get hacked by China the first top half of the month, and then you get hacked by Russia at the bottom half of the month. And you're the one who has to call the FBI and explain it to them.
Okay, all right. And Troy Hunt. Troy Hunt is joining us from down under. He takes a fascinating look into the dark and sometimes funny world of hacking. Troy, are you ready to share some of your adventures with us today?
Geez, my adventures. I think I saw a shark this morning. This is life in Australia, right? Australia, I was about to go out on the water and I was like, oh, there's a lot of fish jumping around there. I might actually just stay on the land where I was going to say I'm safer, but this is Australia. So, and we'll also do some security stuff today, I'm sure.
Yes, you have to worry about spiders and, if you get a list of the, 10 most poisonous spiders in the world, but, 7 of them are in Australia, or a list of, the most poisonous snakes or whatever. You guys really have the most fun fauna, don't you?
That's one way of putting it. We normally put it otherwise. I probably can't repeat just here at the moment, but anyway.
Well, you have cuddly little koala bears too, so I guess they're not all so vicious, huh?
They're all diseased.
Have you seen the claws? And they've all got chlamydia as well. True story. Yeah. Look it up.
Oh, is that right? Oh, good.
Do not hug the koala. It's a trap.
Do you have the world's most poisonous koalas?
I think that'd be a fair statement, yeah.
Clearly, they have a security problem.
So before we jump into security, let's talk about some of the news. We usually do kind of the wrap up on conferences. I think tickets are open for Pacific++, certainly for CPPCon, C++ on C. Have you opened tickets yet, Phil?
Not quite. That's in progress at the moment. Hopefully by next week they should be open. So
okay.
The next PC
and the deadline for submitting has passed, so we've.
Yep, the call for speakers closed on Tuesday, if I remember that rightly, and was completely blown away by the interest. We had 100 submissions in the end. About 101, I think there was an extra one that crept in.
Wow! And you've got spots for how many?
24 at the moment. So.
I do not envy you. I know what it's like to say no to good submissions. I'm not assuming that all 100 are good, but you're going to have more than 34 good submissions there. You're going to say no to some good submissions. Are you looking for reviewers?
Yes, and I've been reaching out to some in advance, thinking that we'd be working through maybe 40 or 50 submissions, but now I think we're going to have to scale that up a bit. So anybody that's interested in helping us to get through those reviews, please let me know.
Okay. Well, certainly anybody planning to attend has a vested interest in making sure that the best ones are picked.
Yeah, absolutely.
Yeah, that's good. That's great. I have a huge teaser we're working for something for CPP Con that I can't talk about, but I'm so excited about it. And I'm just going to tease you and say that for a lot of attendees, it's not going to make any difference. But there's a small number of attendees that are actually going to be really excited about this. It is big, and we're not actually even going to do it for this year. We're going to announce it this year. And in 2019, we're going to have a big change. And I'll be teasing this for months because I'm so excited and can't wait till we can talk about it publicly. Anyway, so what else is going on? Oh, well, the other big news of CPP Con, how could I miss that, is we've got the schedule up. So if you look at the CPP on schedule, you'll see that we have over 100 sessions, and the complaints I keep getting, I'm already getting the complaints. It's like, well, you put all these good sessions at the same time. It's like, yeah, complained about that some more. That's the complaint I love to hear. Anything else we need to cover before we dive in and start talking about security or insecurity or?
Looks like your big secret is out of the bag. Someone in the chat saying that the big news is that GCC will be rewritten in Rust.
That was the secret. That's, boy, who knew that? Wow. So who's going to start us talking about security? What should the average C++ programmer know about security? Is that the place to start? How do we want to start?
Well, in my opinion, the average C++ programmer needs to know that everything is a potential attack surface. You need to be very creative as far as finding and closing as many of those loopholes as you possibly can.
So you're saying paranoia is the answer here?
To a degree, but is it really paranoia if they actually are out to get you is the question that you have to ask there. And that's actually why code review is so important, and why things like red teams, et cetera, people who are
What's
in the know.
Team?
Red team is a security-focused InfoSec team that basically goes through and tries to break existing systems, not just in code and in software, but also like I've worked at companies that had a red team that actually tried to get through our physical security as well. So just because, of course, that's a great way to gain access to a building and get all sorts of information that you can use to really do some damage with later on.
So Ava's making a really great point. You know, Henry Kissinger's there's the comment from him that even paranoids have enemies. And I think the biggest thing that I see is we have a tendency to think that because we're behind firewalls, because it's been tested, I tend to hear we're too big, we're too small, we don't have anything that anybody's really interested in. And those are just rationalizations usually that come from the executives to explain why, when they got hacked, they hadn't done the proper testing. I think the big thing software engineers need to understand is that perimeter security is not going to protect you. If you go look at the laundry list of hacks and companies that have been hacked, these are not small companies you've never heard of. These are massive companies that had incredible security, and every one of them got penetrated. So one of the things we have to remember is that the code that we're writing is the code that they're going to attack. And so that's the last line of defense you've got.
I think that sort of speaks to this premise of, years gone by, everyone sort of said, we got a perimeter. Like everything in the perimeter is good and everything outside the perimeter is potentially bad. And it was a very binary sort of view of things. And then a lot of stuff has changed over the period of time we've been saying that. So we've got more and more assets on the outside of the perimeter. So there's a heap of stuff these days for organizations that are sitting in particularly cloud-based services. We've got more and more untrusted stuff inside the perimeter because we're all walking around with phones and laptops of personal nature and things like that. So we bring a lot of that inside. And the lines are blurring a lot. And this sort of premise of zero trust networking is now gaining a lot more traction, where we're saying, look, why don't we take the same approach on the internal network as what we might on the external in terms of expecting bad actors to be in there. And I think that sort of makes a lot of sense for many reasons. I remember many times in corporate life having this argument with people about, it's the internal network. We can be a bit more lax on security because the attack vectors, or the attack surface rather, is quite different. And there's certainly a degree of truth. I mean, your internal network doesn't have the same visibility in terms of any of us being able to connect to Acme Core's financial systems from our own PCs. but it's like the internal stuff is your financial system and is your CRM and generally holds a lot more valuable data than what the externally facing systems are. So I find it a bit paradoxical that people go, it's internal, like, don't worry about it as much. Well, if it goes wrong, you're going to have a really bad day of it.
They say you're more likely to be murdered by someone you know than a complete stranger, and it kind of goes the same with hacking. If I may take it down, we're just going to go straight down that dark path there. Hi, everybody. Welcome to CPP.
Let's just go right to the bottom at the beginning.
Right.
There's your title, Phil. You're more likely to be murdered by someone you know.
I'll put that on the list.
I can't help but share the story. I spent a long time in my career as a contractor, and there's one company that I was contracting with. I was very happy there. It was a great situation, but they told me, well, management has decided that we aren't going to renew your contract, and we're easing you out. And I said, okay, well, that happens. That's what happens when you're a contractor. But I asked why. I said, well, management just feels that having contractors is less safe than having employees. And I said to my boss, who was really sympathetic to me, he really wanted me to stay. And I said, is that why we have the common term disgruntled contractor?
Well, and that's the thing. What I think most people don't really understand is that when you have a data breach, one, if it's information going out the door, it's more likely to be somebody who's inside the company that is actually doing it. And we see this all the time in secure environments where people are stuffing documents, in their briefcase or down their back and walking out the door with it. But the other part of it is, and if you take the last hack we had at a credit company, it was them getting rid of a contractor, and the contractor hadn't patched anything yet. So if you look at the Equifax hack started, they knew about the vulnerability in March. Equifax was hacked in May. They were in there up until July, but they had never patched it because the person who was supposed to be patching it was like you, as a contractor, that they said, okay, we don't really need you anymore. So it always becomes an inside job at some level, either because somebody failed to do the proper diligence on the servers or on the firewalls to patch the things they needed to patch, or they simply walked out the door because they were disgruntled and they gave it to somebody else. So insiders tend to be a disproportionate amount of involved in breaches that we tend to have.
So I think this is kind of the attitude I had as we were starting this show. It's like, well, I've never really considered that much security, but I've never really worked on a project where that was important, because mostly I work on projects that are going to be used internally or something like that. And but you're saying that those days are over. Everybody needs to be paranoid. We're all paranoids now.
I tell every CEO that I have this conversation with, or CTOs, there are no more safe spaces. Mm-hmm. Bottom line. They don't exist anymore. So you have to treat even your internal systems as if they're exposed to the outside, and you have to harden them exactly the way you would if it's a website. And it becomes even more complicated when you are connecting things to the website, because we tend to see a lot of emergent behavior where we've got very complex technologies that are beginning to filter together, and suddenly you have I didn't realize that's the way that worked, which is why one of the things we go through when we're looking for vulnerabilities is what we want to do is do threat modeling. And so threat modeling takes the entire system as a whole. And what you do is you basically you've heard follow the money. Well, you follow the data. You go and you look at where all the data is flowing, where it's coming from, where it's going to. Am I validating the data? And am I verifying that the person who is sending me that data is actually somebody I should be talking to? And that includes your IPC connections. So a lot of IPC interfaces are based on sockets. Well, if I'm inside the wire, I can now talk to your IPC mechanisms. And if you haven't done anything to protect those, I've got a free shot at your system.
All right. So we've talked about some of the reasons why people are hesitant to embrace security, because they say, oh, this is an internal system. And in fact, I guess the worst situation is, quite famously, I think when Sony got hacked, people said, well, Sony knew they were vulnerable, but they just decided that whatever it cost them when they got hacked was less than fixing it. I think they've changed their mind on that now, because it was so embarrassing for them and so expensive on so many levels. So I think maybe they fix it. But let's step aside the people who are putting up resistance. And let's talk about what is the biggest mistake that people make who really are trying to do the right thing, because they're too naive or they are overlooking vulnerabilities. What is it that you would suggest to people other than changing your attitude and realizing, that now you've changed their attitude, you got them on board. Okay, I'm going to take security seriously. What do I need to do?
I'm not sure, just to scroll back on the Sony situation for a moment, I'm not sure that a bean counter sort of sat down with their Excel spreadsheet and went, security is going to cost us this much. Not doing security is going to cost us that much. Yeah, the ROI on this is good. I'm honestly not sure that organizations are very good at assessing the actual impact of a breach. And in fairness, I don't think I am either, because this is a really, really hard thing to work out. And I think the hard sell that we've got, and it sort of speaks to the question just now as well, is that we're saying when you're building software, there is a component that you need to spend on security. There's no additional features for this. No one's going to pay you more money for it. It's not going to make your product more popular or anything like that, but you've got to spend money to do it. It might stop you from getting owned later on. If it works, you won't see anything happen. It might save you a certain amount of money. We don't know how much it will be. We don't know how bad it would be. And you're trading off.
It not only doesn't give you a feature, it's going to make your product a little bit harder to use.
Well, that depends as well. I mean, if let's take something really, really simplistic. Someone buys a hardware-based firewall system. If it works, then it shouldn't make life harder. Look, if it's two-factor authentication or something, yeah, granted, all right, now there's a barrier to entry and there's a whole other discussion there. But I guess that the challenge is that you're trying to sell something particularly to bean counters most of the time. And I say that in the nicest way possible, but often they're not very. So, you're trying to sell this thing and say, look, we need to invest in here. I need immediate term cold hard cash to trade off against something that might happen later on. And incidentally, it could be much later on. It's not in your budget cycle anymore. You've had your performance reviews. You've met your KPIs. Everything's good. This is some other poor sob's problem now as well. so this is, I think it actually is a very, very hard sell when there's money to spend. But I'd also make the argument that a lot of the time when let's say we just look at coding and we look at, here is the mechanism of writing the code in a vulnerable fashion. Here's the mechanism of writing the code in a secure fashion. Say it's SQL injection, here's concatenated strings, here's parameterized queries. This one doesn't cost any more than this one, right? It's the same number of lines of code, it's just different pattern. And the investment there is then in the education and the training and things like this. So I'm also reticent to say that there's always some big tangible expense, because I don't think that's always the case either.
Yeah, and in fact, in C++, that's a perfect example, because writing something the secure way doesn't take you any longer than writing it the insecure way. It's just how you approach it. What it really comes down to, and especially in C++, we have a lot of tools that are basically free. So there's a lot you can do that really doesn't cost you that much. It really doesn't cost you a lot when you're doing your architecture design to do threat modeling. It's just an extra step. It's not like it's going to cost you an extra quarter before you can release your software. What I think it really comes down to, as far as from engineers, is that they just haven't been trained to do that. We have this idea that somehow hackers are these demigods that somehow have these very special skills, and they do things nobody can really understand. And part of that's sort of pushed by television and movies, that hackers are these brilliant people. And I can tell you, just from knowing so many of them and seeing some of the stupid decisions they make in their vulnerabilities and their exploits, I mean, they're not any smarter than the rest of us. So it really is just a matter of training and education and having people be able to think that way. And as far as the money's concerned, one of the things I talked to somebody about the other day is there are bug bounty hunter programs out there for a lot of the large company, and they're external to the company. But one of the things I was talking about is, look, you need to start a bug bounty hunting program within your company with the engineers who write the software. And so the program goes, if you write the bug, okay, you write the bug, you find the bug, we're not paying you for that, you've already been paid. But if you go out and you find a legitimate bug that is exploitable in your code base, we pay you, depending on the severity, anywhere between $1,000 and $10,000. And so the immediate thing was $10,000. I mean, that's a lot of money. It's like, yeah, but the over/under on your stock drop is going to make that look cheap. So we don't tend to really think about what happens, because nobody really understands how bad things really get when you get hacked. Unfortunately, I've been through it enough times that you realize you'll do almost anything not to have to pick up the phone and make the call, especially if you're working in secure environments. So but the benefits to the engineers of doing this is, one, they're going to be highly motivated to do this. You put cash on the table, they're going to go and learn how to do this. They're going to go and read books on this. They're going to go practice. They're going to go look at how other people do this, and they're going to start doing it inside their environment. So you'll be getting rid of hard bugs that you would not have ordinarily caught. But the second thing is they're not going to be writing bugs themselves, because now they know if you're someone who knows how to hack into a system, you're not likely to write the same bugs that other people can use against you, and you'll catch more of them in code reviews. Mm-hmm. So in the end, you can do most of this for free, but there are right times, in my opinion, to spend money to secure your systems. And unfortunately, you're right. It does not give you a warm fuzzy. You don't have a nice feature you can roll out. It's hard to go sell. But that's the same argument we made about cars. Nobody really cares about security in cars, but that's actually not true. A lot of people buy cars specifically because they are secure.
And, another consideration, too, is not just the expense of actually having to, pay people or fix a bug or something, but there's also a less tangible expense, which is that when you've got a website, when you've got a product, a company, something that people are relying on, and you do get one of these big hacks, one of these big leaks, the damage that's done as far as the cost of user loyalty, user trust, that's something that people don't often factor in. That, yeah, this may not be a big deal to, just go in and fix, but how are you going to earn your user base's trust back?
Yeah, particularly after the Sony leak, I can't imagine it's so difficult to make the argument to just go to a CEO and say, how are you going to feel when your customers, your competitors, your regulators read all the emails that you wrote last year? I can't imagine anybody wouldn't just have any CEO wouldn't have kind of a chill go down their spine when they think about that.
Well, part of it is it's hard to make the case that security is tech debt when you're talking about something like an agile environment and you've got a quarter-over-quarter release of your product that you have to make. Your tech debt tends to be more things that are customer-facing, and it does make it a little harder to sell, because a lot of times you are already behind the curve when you go into the next PI. So, I mean, it's not as easy as, for me, it's a slam dunk. It's easy to sell, but only because I've been through it. And I think most CEOs and CTOs that go through it, you never have to convince them again. But the other part that you have to convince the engineers, because if the engineers don't really see it as their problem, and that's why on my talks, the last line is your first line is the last line of defense. I mean, we really are the ones who have the last shot at stopping a hack. And oftentimes what it comes down to is it's not the big things that get us. It's the little mistakes we make that someone takes advantage of, and then they're in before we know it.
One of the things that always strikes me when you talk about sort of reputation damage and people worried about emails and so on being leaked is you'll see a really major incident online. Think about Ashley Madison. Like, it's hard to think of a data breach that got more social coverage than Ashley Madison. Plus, there's also the fact people literally killed themselves over it. Like, it was a really major event. And you see something like that and you go, okay, so basically everyone in the world who has anything to do with building systems is aware of this. They've seen this. And Ashley Madison was a good example too, because this was not like just SQL injection where they got your data. It was all the code as well. It was internal emails. I mean, this was like total end-to-end sort of ownage. And you see something like that happen, and you hear, like, reporters always say, they go, oh, is this the watershed moment? Like, is this the moment where everyone goes, now we're going to take it seriously? And it never is, right? Like, we see this happen and we move on to the next thing. Now, that was after Sony Pictures, and then we've gone on since then, and we've had Equifax, and we've had Uber, and we've had all these other things. Yesterday was Reddit. It will, maybe not as bad as Ashley Madison, but there will be something else, tomorrow, next month, sometime this year, which will be as equally as bad. And you'll look at the mistakes that have happened, and it will be egregiously stupid things. And it won't just be one of them. It's normally a chain of different things. And the thing that sort of always makes me feel a little bit dismayed is it feels like as an industry we're not improving. Like, we're seeing these things continue even when we see these previous incidents, and you think that would be the penny drop moment, but it just never seems to be.
I think it's just the human condition. I mean, you know that people get cancer, and yet you're still surprised when it turns out to be you or someone in your family, or you know that people get robbed or carjacked or something like that, and yet you're totally surprised when that happens to you. I think what causes that to happen is when it's someone you really identify with. You know, you hear about somebody get cancer, you say, well, but they're not me. You find somebody who really is like you in a lot of ways, and then it really hits home, and that's when you say, oh wow. But generally, that just doesn't happen until it's you. You know, it's always a surprise until it's you.
I hate to say this, but I think the penny drop moment, and there's already a lot of concern over this, especially in federal law enforcement. I think the penny drop moment is when we're crashing planes and killing people. Because a fleet-wide hack is not unforeseeable. Even Elon Musk is concerned about his fleet because you have self-driving cars, you've got upstream servers that are monitoring the vehicles constantly. So anybody gets into those upstream servers, they can work their way down to the cars. Now all of a sudden they've got control of the vehicle. The FBI can already do something similar today. When you pull somebody over, it used to be they had to box them in with vehicles and stop them physically. Now they just send out a signal. It pulls the engine, locks the doors, and deploys the airbags. So we already have a lot of these things, and with DHS already managing to hack into a 757 last year, in actually pretty short time with pretty basic hacking tools, the fact that they could get into the flight control systems is horrifying. And when I saw Boeing's response, it didn't exactly lead me to believe that they were taking this ultra seriously. It was kind of along the lines of, yeah, buy the $295 million upgrade called a 777 because that one doesn't have any bugs. You know, it's all good. Oh, and we're not afraid of flying. That's not what you would expect to hear from a company that is taking seriously. And for them, when you think about a line of code costing almost $1 million to change, it's not like the rest of us where we can hotfix our way to security. They rarely do hotfixes because of all the testing that's involved. So how they managed to get in systems that should have been air gapped but weren't, how a researcher, and he claimed he got in through the IFIN system, which is the in-flight entertainment.
Tell us the story here. You're assuming we know the story, and I don't know the story.
I'm sorry. So last year, the head of DHS admitted that they put an airplane on the tarmac. It was a Boeing 757 in Atlantic City, and it took them less than 2 days to actually hack into the plane from the outside and get to the flight controls.
So this was an experiment. I mean, they did. This wasn't like somebody had hijacked the plane and they were trying to take over.
No, this was a highly successful experiment, which they should never have gotten past. If they were going in through Wi-Fi, they should never. Though when we talk about systems being air gapped, it means they're physically separated. There's no way to get from point A to point B. And in this case, they had some sort of communications buffer that they were both sharing that allowed them to get in. And we don't have the details, and they're not going to give them out, thankfully. But that was 2 years after a guy who lives here in Colorado, who's a security researcher. Troy may know his name. He claimed to have hacked into 20 aircraft through the IFIN system, which is the in-flight entertainment, through a panel underneath his seat up in business class. So in one case, he claimed that he was able to get to the engine controls and issue a climb order, which caused one of the engines to power up and move the plane sideways. Do I believe him? I'm not sure I do. But the FBI took it seriously because they confiscated his hardware and they started an investigation. So if you have people like Elon Musk who have this problem to deal with and they're concerned about it, I think the biggest concern is it's no longer profit motive. When I was a hacker, it was for fun, to prove that I could do it. And then it became about money, to get into somebody's bank account and to steal money, get into their company, steal technology. Now it is becoming, we're starting to see people trying to hack into things where they're trying to go out and harm human beings. And I think that becomes the penny drop moment, unfortunately.
I think in a lot of ways, that's actually easier to do. I mean, imagine one of the things that I could do is if I had a self-driving car, I could break into somebody's car and I could drive them to someplace. That's actually very sophisticated and hard to do. It'd be much easier to just break into every single car and just say, ram the accelerator all the way down and go straight into whatever you do. That would actually, that's a lot easier to do and would cause a lot more damage.
Exactly.
Incidentally, if you do manage to get a plane to fly sideways, we need to have an entire different discussion that's not about security at all. I was just Googling again because I was trying to remember the guy's name. It was Chris Roberts.
Yeah.
you know, just that title. I mean, the first link here, USA Today, FBI computer expert briefly made plane fly sideways. Well, all right, no, he didn't, because no matter how good a hacker you are, there is this whole thing about aerodynamics, right? And probably many other things I haven't even thought of. But it just shows you the hyperbole which surrounds a lot of this as well. Now, having said that, I don't want to get on a plane with this guy, right? Because it sort of worries me too that you've got someone who, all right, let's imagine for a moment he didn't actually make it fly sideways, but he did get access to something he wasn't meant to. I don't really like the idea of being at like 35,000 feet and there's a bloke sitting next to me with a laptop plugged into the whatever it is under the plane. Yeah, basically doing a little unsanctioned pen testing. I reckon give the guy an airplane. Like, give him an airplane, let him reproduce the sideways thing with no other pass. Like, it's not going to happen, but I don't want to be on there when it happens. So I almost feel stories like that are a little bit disingenuous in terms of overplaying the realities of it. And as much as I think we should have this discussion about things like automotive and airlines and things like this, they are fundamentally different environments to where we're seeing data breaches, real data breaches make the news today. This is not like Reddit where there's some bloke sitting there writing some code and he's reused his password somewhere else and now they're into his account. You know, this is not what happened. This is like huge amounts of regulatory control, huge amounts of peer review. And it's not to say these things aren't going to happen, but I don't think that these headlines should be sitting there next to things like the Reddit breach or the Uber or the Ashley Madisons.
I feel like it's also part of how we get things like the infamous 2 idiots, 1 keyboard clip. If you all are familiar with that, it was a clip from an episode of NCIS where they were being hacked.
Oh, yeah.
And they were both typing as fast as they could on different halves of the keyboard to try to defeat the hackers. And it does. And Troy, I do agree that some of the news reporting and some of the media reporting on this is just absolutely irresponsible. And it does lend to that idea that, oh my God, you know, there is nothing we can do, so why even bother? It's like, well, no, it's actually pretty easy to do stuff. It's not like, you know, I didn't get accepted to the College of Super Elite Hacksoring or anything like that. If that does exist, let me know, because I would like an honorary degree. But no, I mean, it's not hard. And like was said earlier, anyone can teach themselves this. If I can teach myself this when I was an angry 16-year-old with too many hoodies and a computer in a poorly lit room, I mean, anyone can. Anyone, especially if you've already got a coding background, especially if you've already got a programming background. It's not hard.
Yeah, I think one of the problems we have with fiction is that we always want to paint the bad guy as someone who's an evil genius. And that trope is a little overplayed, because usually bad guys, if they were geniuses, they would recognize that they could make a lot of money without being evil.
Okay, you want a story about how not genius some of these script kiddies are, and I'm gonna loop myself in there because I was a script kiddie. I was too dumb to run a proxy. So I was doing all sorts of stuff. Matt's dying laughing right now, as he should. I was so like, proxy, I don't need that. I are lead. Type. I make a hacksaw. And yeah, that ended kind of badly for me. And I kind of want to tell that story, except my mom still doesn't know about it. And she might be listening to this. And I'm 31 years old and still afraid of getting in trouble for stuff I did as a teenager.
So there's actually a really, along those same lines, WannaCry. That's the one that would lock out your zip. So this started out as an NSA vulnerability that they'd been saving back. They saved it for a rainy day, then it started raining, so they used it. It got out in the wild. North Korea, they think, got a hold of it through the Lazarus group, and they used that to do WannaCry. So the problem with WannaCry is that, see, they were smart enough to know that when Symantec or Trend Micro is going to look at a virus or a piece of malware, they're going to put it into an air-gapped environment with its own DNS, its own network, everything. And so what they did was, well, we're going to put a DNS and lookup in there to see, and if it's there, to be something nonsensical, and if it's there, we'll just stop. We'll pretend like we're innocent. The problem was these guys were so stupid, they hard coded the DNS that they were looking for in there. They didn't randomize it. It was just hard-coded. So a UK researcher found it and said, well, why don't we just try going ahead and registering that domain?
Yes.
That was it.
Yeah, Marcus
they went-
Hutchins' malware blog on Twitter. He kind of accidentally saved the world. It was great.
So this idea that somehow hackers are these evil geniuses like you see on TV, and Troy, you have a really great video where you went through 2 of those, including the one that Ava just brought up.
Mm-hmm.
It's just nonsensical. I mean, they're not. They're normal people who make bad decisions a lot, and a lot of viruses and malware can get taken down just by finding the mistakes they make, just like they find the mistakes we make.
This is also, I think, the stunning part about it, and I'm not sure if this is the talk you're thinking of, Matt, but in one of them, one of the talks I was doing, I'm showing that the guy who hacked TalkTalk in the UK. Now, TalkTalk's a massive UK telco, and they had a really serious incident a few years ago. That they say it cost them £42 million, and it was kids with SQL Map. And in the video, I show, in fact, it wasn't a video, it's just a couple of slides, but I show a photo of the guy who's been charged leaving court, and they can't show you his face, right? Like they have to blur his face because it's a child. So you've got this child walking out of court who's done some Google dorking, found some SQL Map commands, and done £42 million of damage. And part of the context while I was showing it is the punishment he got was they took his iPhone away only for a year, so he doesn't get to have an iPhone for a year.
They grounded
Which,
him.
in fairness, for like a 17-year-old, this probably feels like a death sentence. You know, I didn't have an iPhone when I was 17, but I reckon that would be a really, really harsh penalty. And he's not allowed to hack any more stuff for a year as well. He's got probation. After that,
After a year, it's okay.
After that, yeah. Now, mind you, after that, he's an adult, and the game might change a little bit if he gets caught either as an adult or consequently reoffending as well. But I just find it fascinating how frequently either children in the legal sense of the term or very, very young adults are able to do this. And we saw the same sort of stuff. Remember all the shenanigans from LulzSec as well, who, you know, like, give them credit. It was funny, some of it. I don't think anyone shed many tears when they owned Westboro Baptist Church. You know, we laughed at that. Many other things, not quite as much. And again, we're talking about a situation where it's a bunch of teenagers whose primary skills seem to be some good social engineering techniques. And any of you who have kids will know that children are very, very good social engineers as well. My 6-year-old daughter is a good social engineer.
They learn early how to play mom and dad against each other. Right?
Yes.
They learn how to do that. It is curious, isn't it, that adversaries that are so underskilled are so consistently effective against large organizations with big budgets.
Mm-hmm.
Yep. Because all it takes is, you know, little mistakes on our part, which we're supposed to be the professionals. And that's, you know, I think that's one of the things that, you know, if I would tell any software engineer, and we'll just stay with C++ since this is a C++ chat, if you do nothing more than maintain situational awareness on who you're talking to and what they're sending you, if you validate your data coming in through trust boundaries, just your external interfaces, we'll just start there, you will eliminate whole chunks of entire classes of vulnerabilities that you put into your code. If you go back, and that's sort of my guilty pleasure, is going back and looking at hacking events and after they've done their investigation and look at how exactly did they get in, and then going and looking at the vulnerability itself and saying, well, how would I have attacked that vulnerability? And how would I have known it was there? Almost everything we come down to is that we're operating on data that we haven't validated and we haven't verified who's talking to us. And then specifically for C++, know the language. C++, I think, is a fantastic language. I think it's actually a fairly safe language in the sense that it's heavily documented. It's very consistent across the domain, but there's a lot of sharp edges in it. Places, you know, anytime you see undefined behavior, that's a sharp edge where under the right circumstances, that's a vulnerability, a security vulnerability. And yet most of the engineers I've worked with over my career, and I'll just go back to 2011 because I don't think anybody realized there was a standard before that. Very few of the engineers that I've worked with have ever read the standard, let alone even know one exists. They get most of their information from things like YouTube videos. But unless you're talking about security vulnerabilities specifically, they don't really know that they're there, and they don't know it. Well, they know it when they step on it and then they get hacked. And that's kind of the hard way to figure it out.
You know, another thing too that I've noticed is no one likes to get a bad code review. No one likes to be told that, hey, the code that you wrote, it's not secure. But we need to also, like all of us, and I'm guilty of this too, we need to listen more. When the evidence is there in front of us, when people are telling us, hey, this is a problem, we need to not take it to heart. We need to not say, oh, my ability as a coder is under siege or anything. We need to say, okay, what is this person trying to tell me? This person is actually just about to save my butt from getting into trouble, because, they're either helping me prevent something from happening, or they're helping me stop making the same mistake over and over again. And I think I can highly edit a story so that I can share it with you about that. This concerns an information leak. My background is very heavily game industry. And it was just a perfect storm of terribleness. I was thrown onto the project last minute because the regular person was not available. I was looking through everything, and it was just very slapdash done. It was very haphazard, last minute. The engineer who wrote the code had ducked out early that day because he just didn't bother. And this is the hilarious thing, left me his Active Directory username and password so I can log in on his machine and test it, which is a whole other part of security nightmare. So I sent an email to my manager and to the department head, and I said, look, I'm not comfortable giving this the thumbs up, because this is a big deal. This is information we're trying to hold back. And I think that there's too many vulnerabilities here. And I was told, oh no, how dare you? He's a great engineer. He's been here for years, and you're just being emotional. That was the direct quote, is that I was being emotional.
Wow. That's not
Yeah.
sexist at all.
There's no sexism there. Yeah.
Yeah, none
I've seen
whatsoever.
code that's made me pretty emotional before as well, if I'm honest.
Right.
I had an emotional reaction to it.
Right? It's like, oh no, I wasn't emotional 5 minutes ago, but now I am. So I did not punch my manager in the face when he told me that, although the thought was there. But as a result of him deciding that this was not a big deal, he never forwarded my concerns on to anyone who could actually step in and prevent this. And as a result, the release went out. Things were not clamped down properly. The information leaked. And I was actually at Disneyland the day that it happened. It was my anniversary.
So were they, by the way.
Yeah, right. It was actually my anniversary of my last marriage. And I get text messages. Hey, you remember that thing? It's out. So, I mean, the upside of this, now the downside is it did ruin their big reveal, and it really, it killed a lot of the magic and surprise about it. Again, this goes back to those non-tangible costs. Luckily, that was all it was, and it wasn't something that was like user information or something really horrendous like that. But, it was one of those things where people had to learn the hard way that when someone says, yo, this is a problem, listen, they're not trying to just be mean to you or hurt your feelings or be a superior coder. They're trying to stop bad stuff from happening.
Yeah, on code reviews, we do have a tendency to have the, I in previous life was just as guilty of it. I don't like the variable names you're using. Your line lengths are too long. Those kinds of things. Mm-hmm. And that's why I think a bug bounty hunter program works, because it gives you, it sensitizes you to what a lot of engineers, they go in there and they can look at something and they just won't recognize. I mean, hacks and exploits are really patterns. When you see the same pattern over, so whenever I want to hack a system, if I've got access to the source code, like if it's something that is open source, the first thing I'll go look at is I want to see every place that you're touching memory, every time you're copying it, every time you're moving it, because I know you're going to make a mistake there. And then that's where I have you. I'm going to go look at all of your external faces and see interfaces, and are you doing anything to validate that data? And I'll give you a quick example from C++, enumerations. We have a tendency to take an integer that comes in and we cast it into an enumeration. Now, before C++ 17, you could get away with that because that was unspecified value if it was out of the range. But when it started C++ 17, it became undefined behavior. And when you see undefined behavior, you might as well just think segmentation fault or general access fault on Windows. So the fact that you're not doing those things means that now when I send you data that you're not validating, you're not range checking it before you put it into the enumeration. And the thinking is as well, it's going to be out of the range. It's not a big deal. I'm checking what's in the range. It's going to fail, and I don't have to worry about it. But now it's what you're doing before that the language itself has now given you a vulnerability that you potentially are opening up. So, and fortunately, there's a fix, and that is you just use strongly typed enumerations, and you've eliminated part of it. You still have where you've stuck something in there without validating it. But those are the first two places I would go in a code review. Show me what you're doing with memory, and are you validating the data that you're operating? Because when you've lost situational awareness on the data that you're operating on, I'll have you. It's very simple. So, but what we don't do, I think, a very good job, especially in colleges and younger engineers, is we don't train them to do that, to hack into their own systems. We have people who are specifically designated as penetration testers, but you have a disconnect. The penetration tester has all the really good information, but now the engineer who's potentially writing the bugs doesn't really have that sensitivity. So internal bug bounty hunters wind up seeing those patterns so often that they begin to see the patterns in their own code. And I know I'll catch myself writing something, no, I already know how this is going to end, and it's not going to end well.
And this is another reason that even having, like you said, having someone to test things that is not the engineer who wrote that code. If you look into some of the ISTQB, which is the International Software Testing Qualifications Board, if you look into some of their documentation, they even say that if you write a program, you should not be the one to write the test cases for that program, because of course you are going to write just natural human bias. You are going to write those test cases to pass. So you really need that second set of eyes, third set of eyes, fourth set of eyes.
It's not even just bias. It's that you wrote your code thinking about all the things that you could think about.
Right.
So what you really want is someone to think about things that you didn't think about, and nobody can think about everything. Right? And
that's another reason why automation, unit tests, things like that are great. They're great tools, and they can help knock out some of this. But it's no replacement for having that human touch to it, that other person with a different background, different set of experiences, et cetera, who's going to be able to look at what you wrote and bring something else to the table. Computers are dumb. Sometimes so are the people using them.
Well, one of the things, and I was going to mention Troy's does a lot of training in this area that I think we desperately, and I'm going to mention one thing a little earlier. I mean, going along the lines of the confirmation bias, it really is simply a different thought process when you're talking about doing code reviews for security. And that's one of the reasons why I know, Troy, you do Pluralsight, and then you have your own training, which is Hack Yourself, I think is what it's called.
Hack Yourself First. Yep.
So, Troy, when you do this training, are you kind of giving people the mindset of think like a hacker, or are you training people to do hacking? I don't mean that in an evil way, but I mean, is that what you train developers? Think, so if you were trying to hack this, how would you do it?
In a way, I mean, when I kick this workshop off, and I've done it probably 50 times or something around the world now, so it's starting to get a bit repetitive. Okay, I'll try and keep it interesting. But like when we start it's usually developers, although there's always sysadmins, testers, sometimes project managers in there as well. It's a bit of a mix. We sort of say, look, this is not necessarily a course to take you and roll you over from a builder to a breaker and go down a path of penetration testing or something. It's to try and give you an appreciation of the world these people live in. So if we look at something like SQL injection, like let's go and actually execute the SQL injection attack, and you will get to explore and craft your own payloads and ultimately achieve an objective. Each one of the modules over the 2 days has an objective. And you'll get to experience that firsthand, because the thing that strikes me is I don't think people building systems really get endorsed in security until they experience it. And I know, looking back at corporate life, so the way Pfizer, many of you know Pfizer, If you don't know Pfizer, you know Viagra. We made Viagra. Anywho, tangential story. One of the things that would happen in this very large multinational organization is have all the developers building software. And what would happen is they would build, let's say, the publicly facing marketing site or something. And then they'd get to the end and Pfizer would say, okay, cool. Now we've got to add security just before we go live. We've got to make sure it's all good. Now, this is the worst possible time ever to add security. It's like any time other than at the very end, because that's when there's no more time or money left, because this is what projects do. And inevitably, there'd be all these problems, and they'd run automated tools, so basically dynamic analysis, pump out a great big document with all these problems, and give it to the developer, and the developer just look at it and go, I can spell the acronyms, but that's about it. Other than that, I don't know what to do with it. And they were never really endorsed in the value proposition of something like SQL injection. I'll give you a really good example of the lack of endorsement. I was reviewing a mobile app at some stage, and I remember I took the app and I wanted to look at the API calls. I proxied it through my PC, proxied it through Fiddler, looked at the traffic going backwards and forwards, found an endpoint called get users, and get users did exactly what get users sounds like it would do. Pulled back every single user in the system with their plain text passwords. And I went to this developer and said, look, all I did is I proxied my phone through Fiddler and I found all this data. And he said, oh, that's okay. Our users don't use Fiddler. And I went, there may be a career in this industry. And I kid you not, this was the answer. So the problem we've got is that people building the systems are often not endorsed enough in how easy it is to break into them. And indeed, why something like just being able to proxy the traffic and see those API requests and then replay them yourself, why that's actually a problem. So I think they have to experience that firsthand. And that's why things like hack yourself first, like get your hands on and break your own things is very important.
Mm-hmm.
So there's a question here on Slack about our opinion on fuzzers, and it sort of leads into another sort of one of my best practices that I'll talk about in my talk is that it's about using asymmetric testing. So I've had people argue with me is that code reviews don't do any good. You should let the static analyzers catch it all. The problem is the static analyzers are not going to catch the deep logic bugs. They're not going to they're only going to catch the things they're programmed for. And most of the time they're catching things like keywords, like whether you're using string copy. But there's an entire ecosystem of tools out there that we use to go after different types of vulnerabilities. So fuzz testing, for those that that are listening that haven't done anything with it, that's a matter of testing exactly what I was bringing up with enumerations. You're putting in garbage data into an interface, and you're letting that interface see if that interface can handle it. But there's a lot of other things. Like when you run your performance, stress, and scalability runs, you should be running dynamic analysis tools along with them, looking for threading issues, looking for memory contentions, looking for all those things that you're not going to see in your baseline testing, the things that you're doing at your desk, or even that QA is doing where they're doing functional or regression testing. This is where you are leveraging the system up to its highest amount of pressure, and that's where you're going to find a lot of these more difficult to find bugs. And then, of course, we have penetration testing, but I'm still going to claim that the very best thing you will ever have is a well-trained staff that knows the patterns of exploits, because they've studied them, you've turned them into bug bounty hunters, or just they are like me. They started out on the wrong side of the tracks, and then that just sort of became the way they're created. So I did most of mine in law enforcement, in the Department of Defense. So these are big targets, and a little mistake is enough to get you burned. So,
but wait a minute, how long have you been doing this?
I've been doing this professionally for 30 years.
Okay, so my point is that that's not really a solution in scales. If you're saying, oh, well, we just need to teach people to have the experience I have that took me 30 years to get. That's
no. In fact, you don't.
So how do we get people up on this? Everybody just have to take Troy's course? I don't think Troy's going to object to that, but I don't think he can handle it.
No, see, Troy's course comes from the outside. I mean, I've seen, I haven't been in it, but I think it's coming more from the OWASP side. So it's coming from, you're coming in from the internet side. Where I sort of learned it was sort of coming from the other direction, which was from the C++ side, from actually doing development. It doesn't take 30 years. It simply takes people beginning now. In fact, I gave this talk, and someone who was a product manager came up and he said, I only have 3 engineers. I can't really send them training. It's like, you can start. You can start by having people go out and begin. A lot of these fuzz testers are free. A lot of the dynamic analysis tools are free. They don't cost a lot of money. A lot of our static analysis tools are free as well. So it doesn't have a very high economic threshold to be able to get into this. A lot of it just is a willingness. A lot of it, I didn't go to any special training, and it didn't take me 30 years. The 30 years has really been how things have changed. I mean, I came up when there was no internet. I was hacking BBSs. That sort of gives you an idea of how old I am. But it changes, and I'm constantly having to go and learn and relearn every year, because in fact, the vulnerability that I did at C++ now, you really can't make that work that way anymore. I did it really just to sort of sensitize it.
So the background here is, in your talk at C++ now, you actually did a hack and let the audience watch how you hacked.
Yeah, I walked them through exactly how it works, and then we did it live in a VM. I'm going to do the same thing at CPPCon. Yeah. In the second talk, I'm going to do one that can actually be successful today. It's a completely different exploit. In fact, it's one that was exploited. So it doesn't take you 30 years, and I can tell you...
We need to have the volunteers screen out any FBI agents that might be in the room, or is it legal for you to give this talk at CPPCon? Do I have a liability that I need to think about it?
You always have liabilities with me, John. It's called Unfiltered Thoughts. No, it isn't. And the reason why is this is all known. If you spend any time, I mean, if you can go and look in the common vulnerables, they will show you exactly what they use to get in, like the Heartbleed in the Heartbleed exploit in OpenSSL has been very well documented. It's just, so here's the thing. Most engineers, in fact, I had people who will come up to me and say, well, how can they do that? I mean, how can you run code just by overflowing a buffer? And so that's one of the reasons why I did it, was I actually showed them exactly how it works. So I diagrammed it out, and then I did it live. And so it becomes one of those things where it's like trying to find an honest politician in Washington. I mean, theoretically they exist, but until someone bags them in the wild, it's just theory. The same thing goes on with exploits. People can't figure out how these little simple mistakes can burn you so badly. So that's why I brought up Troy's training. That's why I'm doing a lot of the things that I do in my talks, because these are things people need to know. Engineers that do this every day, day in and out, need to know that these are the things that can burn you really badly.
I wonder also if organizations are sort of looking for the panacea, if they're sort of going, give me the security in the box, like the thing I can do, whether it's like the one training course or the one tool or something like that. And I think that's sort of like, I understand the temptation, but that's really not going to happen. The static analysis example is a great one. You're going to find a lot of stuff there. You're not going to find the fact that someone's just published your Git repository to the root of the website. And this is what happens. There are Google Docs that show you many interesting things like that. So it is going to be more of an ecosystem of different controls, and I think that training is part of that, and automation's part of that, and there's also a cultural part of this as well. One of the series we've been doing on Pluralsight, we've got this free in front of the paywall thing about creating a security-centric culture. We started doing, because when I was meeting customers last year, like the one thing all of them said was, like the hard controls and the training and everything are great, but how do we get everyone thinking differently about it? And I wonder if maybe that's like the umbrella that we need to get sorted out. Like, how do we get everyone in the organization, from the person at the top down, thinking that this is something that we need to bake into everything that we do? And I think until that sort of permeates the culture, it's going to be hard to really achieve the goals that organizations want.
I think ultimately, sorry, go ahead.
I was going to say, part of it is, I mean, most of the things that you're pointing out, it's, oh, that's an exploit. I just look at that. No, it's a bug. I mean, what you were saying is it's people having difficulty understanding why. Well, okay, big deal. It's an overrun. How is that exploitable? And to me, it's like, yeah, that's going to be hard to exploit that, but I don't care. It's still a bug. I have to fix that. I can't have that kind of bug in my code. That's just unacceptable, whether it's exploitable or not. And there are people who don't have that attitude. It's like, well, yeah. Theoretically, that could happen, but I don't have to worry about it because it's not going to happen. And the security implication is, well, someone could go out of their way to make that happen. But there's an attitude thing about, no, I don't care if they're going out of their way to make it happen or not. I can't have that in my code. I can't have that. Whereas there are people who are going to say, look, I can't protect against absolutely everything. Your computer could melt down. I can't write code to prevent that, right? And so they might back off. But we have to have an attitude that says, no bugs are acceptable.
Yeah, and that's a great point, because I've seen it go both ways. I've seen companies where they tried to start it from the top and work its way down. The CEO or the CTO passed the edict, and the engineers are like, whatever. I have to hit my deadline. I'm not really worried about what's going to happen in 6 months or a year. I've seen it go the other way, which is the engineers are really charged up on this because they understand the issues, but you've got nothing from the top because they're afraid it's going to cost money. It's going to push deadlines. People want training, those kinds of things. So they don't want to spend the money. What it really comes down to is it has to be an organizational change that goes from the top to the bottom and crosses different boundaries. You have to have engineers that are serious about doing this and serious about learning, because they're going to have to take the time to learn how to find these things and how to change their testing. But then you also have to have buy-in from the top. So it really works best when it's organic from within the organization at almost every level.
Were you about to say something, Ava?
Oh, no, I was just thinking to myself, you had made the comment earlier about how sometimes people say, oh, no one's going to actually do this. No one's going to, no, it's very low chance that someone's going to exploit it. And my argument to, oh, no one's going to do this was always, I've done it. I mean, that usually once my team got to know me a little better and realized what I was talking about, that became enough to shut down that conversation.
So that is one of probably the only upside for having started life as a hacker, is that somebody says, yeah, nobody's going to do this. Yeah, sorry. I mean, yeah. I hate to destroy your perfect world here, but the one thing I always tell CEOs or CTOs is, what? Hackers are bug bounty hunters. Unfortunately, they don't work for you.
Mm-hmm.
So
that's very true.
It doesn't really matter at an engineering level. If the vulnerability is there, the vulnerability is there. And at some point in time, you're going to get on somebody's radar. And that is, and I think you brought up a good point, John, is, it's a bug. If it's a bug, it's a bug, and you have to fix it. But not all bugs turn into security vulnerabilities. So we do wind up having to prioritize anything that could potentially be security vulnerability. But if you don't know how somebody could do it, like in my talk at C++, somebody literally stopped me in the middle of the talk and said, but how can somebody do that? Which is the reason why I showed them in the talk exactly how to do it. There really is sort of this disbelief. And then it becomes, okay, that got hacked. It must have been some, serious problem. And I will tell you right now, these are little small oversights that if you don't recognize the patterns of vulnerabilities in code, it's very easy to just walk over them, and you don't ever see them as a bug at all.
Mm-hmm.
Okay, so we're ticking away our time here. I want to give you a chance to tell me why I need to come to your session. You've given a session at C++ Now. You're also going to give a session at CPPCon. Is this only for people like Ava who are all about security, or is this for everyone who writes code?
I'm giving 2 talks at CPPCon. There'll be Monday afternoon, I think, is when you've got me scheduled. The first talk is going to be for really just for anybody who has ever asked the question, how do these things happen? So you don't have to be somebody who has an active interest in security, but if you want to go and see how a buffer overflow exploit is used, how your code can be penetrated, the first hour of the talk is going to be that, and then I'm going to do this probably a little more sophisticated version of the one I did at C++ Now, and at the end of the first hour. The second hour is about remediation. What can we do at a process level? What can we do in our testing? What can we do in our code reviews in order to make sure that we catch these things before they go out the door? And at the end of that one, I'm going to do a different exploit. Again, I'll do it live, but what I do with all of them is go back and look at, if somebody's trying to penetrate you, these are the artifacts you're going to see. I actually use GDB to go in and look at the stack space in the case of the buffer overrun to see if you can see the patterns. Again, it's about getting engineers to understand the pattern. So this is really just a primer on both ends. How does it happen, and how do we write our code? How do we test our code? How do we release our code in such a way that we protect ourselves from that? So it's not going to be so high level that you have to have a PhD in security to be able to understand it. It's really for anybody who has an interest or thinks that that's something they want to put into their environment.
But I'm definitely going to it.
Well, as an additional, I don't know exactly what to say. An additional promo for this is that this is going to be one of kind of the themes of this year's CPPCon, because we've already announced that we're talking about Spectre, which I don't think you're going to be touching on that in your session. Is that right?
No, Spectre and Meltdown are actually hardware exploits more than they are software, and there's not a lot in C++ you can do to protect yourself.
So, but that is one of the things that we're going to have. Chandler is going to talk about that in a plenary session, and then we're going to have the closing panel is going to talk about that. And he's actually got someone from Microsoft and someone from Red Hat, and he's been doing this at Google, where they've been doing some things that, for obvious reasons, have not been made public, and they're going to share what they can about what those companies have been doing to try to protect us from those exploits. But this is certainly going to be a theme of CPPCon this year, is to talk about security. So yeah, we do kind of need to wind up here. I don't want to cut anybody off if somebody's got something to say. Troy, when are we going to see you come and do a session at CPPCon?
At CPPCon, not this time round. I'm trying in vain to travel less. I've been away I think almost 40% of the year, and I really like where I live too. So I don't know why I'm doing that. But having said that, you can catch me in. I'll be at a bunch of Aussie events actually. In fact, I'm going away for 3 weeks on the weekend to do a bunch of talks. Yeah, snowboarding for a week. We have snow in Australia. Oh, people know this. We also have angry animals in the snow too. That's another thing. And then if people are in Australia, I'll be at NDC Sydney in September. I'm actually going to be at a couple of events in the US in October. I haven't announced yet. And also, as part of me trying not to travel as much, I'll be at another one in North America at the end of the year. But I don't think one's announced yet, so I'll share that when it comes up.
Okay. Ava, do you have anything you want to tell us about? You're going to be at CPPCon this year.
Yes, I am going to be at CPPCon this year. I am super, super excited for it. I have missed everybody, of course. And hopefully I'll see some familiar faces. Please don't be shy about coming up and saying hi.
Okay. Well, we've definitely talked about that you're going to be there, Matthew, because you're going to be giving a talk. Did you get a chance to look at the schedule? Is there anything else you're excited about?
Oh, Sean Parent, Jason Turner, Ben Dean. I mean, the list goes on. My biggest problem was I had all of these that I wanted to go to, and had a lot of them had conflicts. So I have to get some of them on videos. But yeah, I'm very excited about CPPCon.
Well, the good thing is you're speaking on Monday, so you got that out of the way.
I do. And
certain speakers is that you never see them before their talk, because they're in their hotel room working on their slides until the last very minute. You always know when Michael Case's talk is scheduled, because you don't see him until his talk is given. Then you can see him.
Yeah, and this will be my first CPPCon, so I'm very excited, especially to get a chance to meet a lot of the people that I've known online that I've never actually gotten to meet in person. So it'll be a good time.
And you're going to be joining us, Phil?
I'm going to be at CPPCon. I've got 1.5 talks, and I've got a 2-day course to do. So hopefully I'll make it there.
All right. Well, thank you guys all for joining us. I don't know if you've made us feel more secure or less secure. I think you've probably made us feel less secure. So this podcast is not only the least secure, it's now even less secure than it was at the beginning. But I want to ask you to join me in wishing everybody safe coding until our next episode.
Safe coding.
Safe coding.
Safe
Thanks,
coding.
guys.
Everybody.
Safe coding.